Hi, welcome to Teardown Tuesday. We're going to take a look at the Rigol DP832 power supply because a lot of people asked for it. So we'll just do a teardown pretty quickly to see what makes this thing tick. Now the interesting thing about this, of course, is that it is a software upgradable power supply. So that means that, of course, the hardware in this could be identical to the 832A, which of course has all the options in the back, plus the color screen. I mean, this one has a color screen, but it's just software limited to monochrome and stuff like that. So this should be interesting, and I think we will find that the hardware in this is identical to the 832A model. But we won't find out for absolute sure until we open it up. Now, there was a report on the EEVblog forum about somebody found a bit of rust inside their unit, so we'll see if that's the same case here. Rust on the chassis, I would presume. So we're going to whip this apart, and it doesn't look like I need to take these rubber feet off here. It looks like it's just going to slide off. And it looks like my warranty void, if broken, sticker is already a bit broken due to the fact that, you know, the chassis does bend a little bit of give on the bottom like that, and it is almost peeled off. Well, we can fix that. Ta-da! Now it's completely gone. It turns out that we do have to take off the side handle here, because that's the two main screws, actually the only two screws actually holding this case on, apart from the rubber feet at the back, which weren't directly connecting the chassis in. But anyway, so what we expect to find in this is a basic, you know, a fairly, not a high-end processor. Of course, there'll be, you know, a huge, whopping big transformer in this sucker, big linear transformer, plus some basic processing, handle all the user interface and the networking and all that. Enough to, you know, it's going to have to be powerful enough to run a little OS in there and do all the networking and you know, file stuff and handle the display and all that. Plus there'll be some you know, fairly precision analog to digital converter and DAC stuff, because this is a 0.05% class precision power supply. And really not, you know, probably on a couple of boards and not a huge amount of extra stuff. So let's, got a big toroid. Check this out. Ta-da! There we go. We're in like Flynn, and that's it. Looks like it's shielded on top. I'm rather surprised at that. You don't often. Yeah, it looks like there's a board on top as well. So looks like the power supply board on top. Anyway, we'll open the sucker up, and but check out that big. That's where most of your weight is, in that huge toroid. And I'm very impressed with the huge toroid transformer in this thing. And of course, a toroid transformer is going to be the duck's guts in something like this. It really is. And you're probably paying a bit of a price premium to get that toroidal transformer in there over your traditional laminated transformer. Now, there are several advantages to a toroidal transformer like this over your more traditional laminated core transformer. One of the biggest is that you get an increase in efficiency in terms of size and weight for a given power for these toroidal transformers. They're just much more efficient due to the fact that they don't have all those separate laminated layers. You get better flux efficiency inside the thing, and that leads to a reduction in size and weight for a given power of that transformer. So this is what, 195 watt power supply or something like that. In theory, this toroidal transformer should be smaller and lighter than an equivalent required one in terms of efficiency for this particular wattage power supply. Now, the second advantage is stray magnetic fields in this thing, because there effectively is no air gap inside this thing. It's just one large toroidal core like that the wires are actually wound around inside that. No air gaps means much less stray magnetic fields for these things, and that's why they're used in audio, you know, really high-end audio gear and stuff like that. Just much nicer design than your traditional laminated core type. So huge thumbs up. And it's also mounted on the little stamped out feet from the chassis here with what looks like captive nuts actually built in to the chassis down in there. So that really is quite neat, and it does look like there are some shake-proof washers down in there as well. Now I can potentially see why somebody may have complained about rust on their particular unit. It's a very similar folded sheet metal type thing with the riveted together that we saw in that Siglant unit, but at first glance I can't see any real rust on my unit at all, not even close to the Siglant unit. Hang on a sec, I did find a little bit of rust on the back top end of this thing, but once again, nothing like the Siglant unit really. I mean, yeah, it's there, so yes, okay, technically this unit has some rust, but the cutout in the back chassis, I guess we'll find out more when we get into this thing, but it just seems to have a much higher build quality than what we saw in the Siglant, even if there is a little bit of end rust there from where they've obviously lasered or sheared off that particular part of the metalwork. And I do rather like this top board modular construction here. If we whip that out, hey, we've got some heat sinks. It looks like we've got, yeah, hang on, and that just flipped out rather nicely there. I'm quite pleased with that. We're going to have to undo all the board interconnects and all the wiring harnesses to get that board out to have a proper look at it, but the board quality looks to be first class, as you'd expect. And we'll have a brief look at the top board here, because the top board is slightly different to the bottom board. The bottom board's got 2 channels, as we'll see. The top board only has 1 channel, essentially. So the interesting thing is that there's no processing stuff on this board at all. It's all your analog power supply stuff, all in the center here, and you can see the isolated path around the board here, which goes through here like this, and then we've got a couple of opto couplers down here for some serial data going across there, and of course all of our output grounds on all of our comm stuff, our Ethernet, our USB, and our logic outputs, for example, and our RS-232 are all, of course, electrically isolated from the output of the supplies, and they've got their own little power supply circuitry up here, powered from a couple of little taps on the transformer up there, and then we've got our ribbon cable going off to our front panel board in here, which obviously contains all of the processing for this thing, and they're just feeding that data for the Ethernet and the USB and everything else straight down to here. And any mystery to do with is this different hardware with the A model? Well, that's pretty much solved. There it is, DP832A. They've got this on both of the boards, silk screened on, and also the sticker as well. So this is definitely an 832A unit, and the 832 is just software crippled. That's it. So even their assembly sticker there tells you it's an 832A. And if we have a look at the analog part of the main power supply board here, we can see that we have no less than 4 chips laser marked off. This one over here, this one down here, and that one in there. Bastards! Why? It's not going to take anyone a huge amount of time to reverse engineer this. You've got to be kidding me. And there's our main little, what looks like a processor or something like that perhaps. Obviously it's right next to a little in-circuit, an 8-pin in-circuit. Programming header there. Laser the thing off, you can almost see a few of the start letters there. Anyone want to have a guess? And that's coupled down here to another 8-pin SO package, completely marked off there. It's got guard trace all the way around here. Look at that, so you can actually see that's obviously, not just like an I2C chip or something like that. It is some analog signal there that they're trying to guard against. And you'll notice that here, what looks like our voltage reference, I'm not going to try and, decode one of these SMD marks. They're a pain in the ass on that SOT23, but why have they routed out that little slot around there? Well, that is to isolate that device from any thermal stress on the board, because when this board warms up, which you'd expect to happen inside a power supply, for example, then it doesn't apply stress to the leads as the PCB material stretches just a little tiny little bit, half a bee's dick, but that might be enough to induce stresses into the lead of that voltage reference package there. So that's a very common technique, just route out around like that and you get away from all the thermal stress issues. And we've got some retro action here, 74HC4051, fantastic, and TLO74 quad op amp. Beautiful. Couple that into a TLO72, dual version of that same device, and we've got another SO8 laser marked off, and another one up here as well. So whether or not those three SO8 chips are all identical, I don't know. But you know, it looks like it's just it looks like it's a bloody op amp or something like that. I mean, God, who cares? And to complete the retro rollout, LM393. Woohoo! More of that action down the bottom side here of the board, and we've got ourselves a freestanding LM317 there. You know I'm not always keen on those freestanding packages like that. We've got ourselves a transistor in there. Sorry, I can't make out the markings. It's really incredibly dark in there. And that's got its own little tiny, teeny weeny pissant freestanding heatsink. But the big heatsink here has one pass transistor on it. I'll try and get the code off that, but once again, quite dark in there. And that's a SEP80N15 N-channel MOSFET, of course. No surprises. 150 volt, 76 amps nominal rating. So pretty much what you'd expect in there. And the other one on the smaller heatsink, by the way, is a old school retro BD136. And there's our current shunt resistor, 20 milliohms by the looks of it, 1%. But once again, absolute accuracy of this thing doesn't really matter. It's all about the tempco and how you trim this thing out in the software. So 1% is certainly adequate there if you're going to software trim. No idea of the brand, but there you go, SMT C0804. And no shortage of protection on this thing. This board has 4 MOVs on it, and these two are associated with the main output rail there. And then our transformer tap there is protected by a 5 amp axial PCB mount fuse, and we've got no shortage of protection. There's 3 other PCB mount fuses on there as well. Very nice. And all the caps in this thing, both the small and large ones, are all exclusively Samyang brand. Now they're actually a Korean brand. Of course, they're not one of the top tier ones, that's for sure, but I don't think they're bottom of the range. They are all 105 degrees C rated, so meh. And the main 2200 mic caps there look like to be the TDA series. Once again, we've got a bit of edge rust on there, but that's all it seems to be limited to, is just some of the edges that have been lasered off. And we've got ourselves a heatsink with 2 large bridge rectifiers in there. There's one down there on the other side. And down in there you can see 2 Cosmo 3021 triac drivers there. So obviously I can't get a look at those devices U17, U21 down in there, but they're obviously a pair of triacs. And they've gone to the effort to Celastic down these 2 smaller caps here, but they didn't bother with the larger ones. Now I'm debating whether or not it's even worthwhile trying to extract this bottom board down here, because it's clearly 2 not identical, but you know, fairly operationally identical channels here. You know, similar arrangement here. You can see the triacs over there with the triac drivers. You can see the main caps down here. You can see the output. Once again, all those MOVs protecting the output there. Look, huge number of them. We've got our mains input here, which we'll take another look at, but we've got a tiny little separate heatsink down in here with our bridge rectifier, and well, it's pretty much you know, identical to what we just looked at. Yes, we've got our chip. There it is. It's ground off down in there. You probably can't see it, but right down in there, there's the little in-circuit serial / JTAG header right next to the thing. And really, you know, not much else, except, look at that. They haven't left it loosey-goosey. They've actually bolted that TO220 down to the board. They didn't do that on the other one. Just couldn't be bothered. And they've knocked some EMI on the head there with that little ferrite clamp around the output leads. And in terms of packing density in this thing, it's pretty darn good. I mean, with the board on top that flips over with the heatsink going down, there's not a huge amount of room between those heatsinks, and Airflow, of course, is going to come in from the side vents here on the outside part of the case, sort of, over the transformer a bit, and then through the heat sinks, and then going to be sucked out the fan at the back. So not too bad layout at all. And you'll notice the daisy chain serial connector here going down to the bottom board, and really that's the only data that comes from the bottom board. Everything else in there is just input output power wiring from the transformer and all the front panel. So all of your data is set and read via this serial link. Via this serial link here onto the main board, which then of course we've seen goes to the mains earth reference part of it here, back to the main processor on the front panel. So each power supply module here for each channel must have its own onboard processing, onboard voltage reference, and also analog to digital and digital to analog converters. Now if you have a look at the mains wiring here, I've actually disconnected these red and black ones down the bottom. They're the two, they come directly from the IEC mains input down here, and they go through these two cable ties here, and they go down to the switch on the front panel down in there, double pole switch, and then that comes back to these two, which I've disconnected down in here. And sorry about this, it's a bit convoluted, but they come back to a little isolated section of the main board down the bottom here, which has some input protection and some filtering as well. And then that goes off all the way back here. It's a little bit convoluted, but it goes all the way back to the voltage selection board, which is really good because they've got a insulation on the back of that. And then that goes out from the voltage selection, goes all the way straight into our toroidal transformer. Now if we have a look at our front panel terminal board, you can see this is our common grounded one. So this is our 5 volt output here, and this is our 30 volt with the they're the two that actually have the common ground. Even though they don't actually look to be connected at this particular point, they will be connected back further on the board. Now the first thing you'll notice, of course, is that there's 2 wires going to each one, a power wire and a smaller sense wire. So this thing does actually do front panel terminal sensing. There you go, they got the wires going back, and that's the same on all of the channels here. There's the other 30 volt output one, and yeah, obviously they've done that because they have to. This is a precision power supply. You've at least got a sensor load at the front panel terminals, and they've gone into all the effort to do that, as you'd expect. But the obvious oversight is, well, if they went to all that trouble, why couldn't they include a little bit of switching and some sense terminals on the back panel or something like that? I guess, I don't know, feature creep, maybe, perhaps, or, they leave that to the higher end models or whatever. It's one of those differentiator things. But anyway, they have done that, and there's no shake-proof washers on these either. You'll notice that the nuts have actually been soldered down to the ground planes down there. Not sure if I like that. I would have liked to have seen some proper shake-proof washers with some Loctite. That's a bit how you doing. I've undone a couple of screws on the side, and I'm going to prise off the front panel here. Hopefully I can get it out in one piece, and we'll be able to see all the main processing on the front. And there's really not much doing here at all. I might have to take this board out and flip it over to have a look at the part used. But obviously, look, there's only one BGA device here. You can tell by all the vias in there and all the decoupling around that, of course. Looks like we might have some JTAG programming interfaces here, perhaps. I don't know. We'd have to flip that open to have a look. And then we've just got some ribbon cables. This one goes over to the keypad. This one goes over to the LCD. And as we've said, the LCD is it appears to be the same on both versions. And that's just one of those module things with some circuitry on the flex there, some driver and inverter stuff on the flex circuitry. And then we've got our other ribbon cable, which heads off back to the main board for all of our rear panel and control interfaces. Now you can't see it there, but I'm a bit surprised to find a 1000 mic output cap there. That is, 1000 mics is pretty darn high for any power supply which has a constant current capability. Why? Because on a supply with constant current, at any time it can switch into constant current mode, but that constant current might be limited back further on the board, but then this output capacitor here can deliver a spike of current, energy directly into your load over and above that set current amount. So during that switchover period, so really the design goal when you're designing any lab power supply with constant current mode capability is to minimize your output capacitance there, but they've whacked in 1000 mic, which is pretty darn high. Now, whether or not they've done that because that was the minimum value that they required for output stability, I have no idea. You'd have to go into the circuit and the actual design and the loop performance of this thing. And just like on the Siglent, I'm very disappointed to find this crappy folded part of the metalwork here that the ribbon cable goes through. I don't, like the quality of the construction in terms of the metalwork, although yes, admittedly this one is better than the Siglent, but still, I don't know, it's a little bit ugly, but still there's not much rust in this one at all compared to the Siglent. And here's the main board, and there's a bit of a surprise in here. Instead of the usual analog devices, Blackfin DSP we find in a ton of other Rigol gear, but they've gone for a Freescale IMX 283 ARM applications processor, and this has got an ARM core running in it with a whole bunch of stuff. It's got a high-end ADC and DAC and all Ethernet PHY and all sorts of stuff designed as sort of a one-chip solution for everything. But I guess they optimized the cost of this thing. I guess maybe the Blackfin DSP was more expensive, but I guess they figured that's all they needed to run this thing. I mean, it doesn't have to do any heavy DSP. It's just driving and a graphical LCD and reading a keypad and doing some serial and maybe some Ethernet is probably the hardest thing this thing's got to do, really. So I guess they optimized that down. I found that a bit surprising anyway. And obviously the JTAG header for that one is up the top here, but look at the flux residue left from the hand soldering process there of these connectors. I don't like that at all. They spoilt the thing. And otherwise, it's the reflow soldering quality is very good. And once again, another couple of hand soldered connectors down the bottom, very sloppy. They haven't bothered to clean it up. Quite disappointing. Don't really expect that from Rigol. And the other device is actually an 8051 processor. There we go. So we've seen a similar sort of thing before in terms of we've got stuff like LAN clock and things like that. So maybe that's just a small processor to control the LAN, but maybe this other connector here is just a well, it could be the programming interface for that 8051, but it could also be a serial monitor, a debug type thing, maybe where they actually, program the flash memory and handles all that sort of stuff and programs the OS, allows you to get all sorts of debug information out and stuff like that. And in there we have a WinBond SPI flash memory tucked away, so what that one's holding, I don't know, your guess is as good as mine. And of course the good thing about these application processors, they always have their own, or usually have their own power management built in. So you can see it's got its own, part of the die over here is all dedicated to the switching circuitry for its own core. So it's got all the switching built in, and you just need a couple of, externally inductors and caps, which can sometimes be bigger than the entire bloody processor itself. And that one handles all its own power. So let's power up and see if she still works, shall we? Will the magic smoke escape? Hope I put everything back. Woohoo! Looks good. It's booting. Fantastic. So there you go. That was the Rigol DP832/832A bench power supply. And yes, it is. It looks like it's an absolutely identical model to the 832A. You just pay for the software options, but that's not very surprising at all. That's what pretty much everyone expected, and the design and build quality is not bad at all. Yes, I am disappointed with the chassis, with some rust on there, and also, you know, just a little bit of sloppiness here and there in terms of that. But yeah, I know a lot of people complain, oh, it's just as shit as the Siglant. Well, bloody compare the two. It's not. This one is the finish and polishing. This one is much better than the Siglant. The Siglant was absolutely shocking compared to this one still. So yeah, there was a bit of edge rust there, but really that's where it was confined to, just those laser trimmed edges on the exposed parts of the metal work there, but you know, not nearly as bad as the Siglant, not even close. A lot of people said, you know, there was nothing wrong with the Siglant one either, so make up your own mind, make up your own opinion, but I think this thing is designed and built pretty well. I love the big toroid transformer in there, very nice indeed, and the dual board construction, and it is rather nice. And yes, it's probably you know, you can experiment and hack around. You can even get access to those, easily get access to those external sense terminals. So if you wanted to really, you know, hack a connector on the back panel or something like that for external sensing, I can't see why you wouldn't do that. It's well, those sense inputs are well protected as well. They got the MOVs on there, and yeah, it's not too bad at all. So there you go. That's the Rigol DP832/832A power supply. Hope you enjoyed it. If you want to discuss it, jump on over to the EEVblog forum. Catch you next time. Oh, and by the way, the high-res photos of this thing will always be available on my Flickr account. In fact, a lot of the teardown photos are often available on my Flickr account before I even upload the videos. So there you go. Bye.